Hello once again and welcome to section 7, which is still on production theory, but this time I'll be treating production in the long run, right? So this section continues by focusing on production in the long run. And it begins by explaining homothetic and homogeneous production functions, the isoquants, which is a combination of inputs that allow firms to produce a unit of quantities, and then subsequently we'll provide details on the long run production function. In terms of the outline, we have homothetic and homogeneous production isoquants, and the list goes on like I indicated over here. The outcome is that at the end of the day, you have a good working knowledge in homothetic and homogeneous production functions, identify an isoquant, determine optimum bundles of production, explain the law of diminishing marginal rate of substitution, and the list goes on. So in terms of the reading list that we have chapter 29 of Varian and Hall, right? And then the session slides and any other intermediate micro. So what are homothetic and homogeneous production function? A homothetic production function has the following properties. So f of x as a function of f of y implies that when we increase f of x by a function lambda, it means that f of y is also by the same lambda, right? So by changing the production factor by a constant factor affects both x and y, right? And then with homogeneous production function, it has a property where f of lambda x is equal to lambda k f of x, right? So if a production function is homogeneous of degree 1, it means that k is equal to 1, meaning that there is a constant returns to scale, right? So homogeneous implies homothetic, but not conversely. So from here, you can tell that when a function is homogeneous, it is also homothetic, but a homothetic function is not necessarily a homogeneous function, right? So in the long run analysis, we know that capital and labor are variable, right? So we have a typical Cobb-Douglas production function where Q is a function of labor raised to the power alpha and capital raised to the power beta, right? So our production isoquants gives us a summary of all combination of inputs, labor and capital, that gives the same level of output. So here Q6 is produced, Q9 is produced, and Q12 is produced. So the farther away from the origin an isoquant is, the greater the quantity that is produced. In terms of the slope of the isoquant, it is a change in capital over a change in labor, right? The rise over the run. So here, this is our production function, Q as a function of K and L. If Q is equal to 20, it implies that we can equate it and find the marginal product of capital and labor as well, right? In terms of the properties of the isoquants, I have discussed, the slope is a downward slope isoquant, typical. Isoquants are downward slope, which is your typical convex isoquant, and the curvature of the isoquant indicates how readily a firm is able to substitute capital for labor. So if you have an isoquant that is shaped like this, then you can tell that these are products that are substitutes, right? Factors of production that are substitutes. It's either you use A or B. Then factors that are complements in production will give what? L-shaped isoquant. Will give L-shaped isoquant. So a convex indifference curve isoquant, which is the same as indifference curve under consumer theory, is this scenario where you have, so compared with kinged isoquant, which assume limited substitutability. So I would want you to read on king isoquant. With king isoquant, the firm cannot easily substitute one for another, just like the complementary goes. But with your convex isoquant, the firm can substitute capital for labor along a given isoquant, right? Or in terms of the marginal rate of substitution, we want to look at how capital and labor can be substituted for each other, and that will give us the slope of the isoquant, right? So here we have our production function, and we want to look at how to find the slope of the production function. So we'll take the total derivative of the production function. So d with respect to labor, right? And we get the marginal product of labor plus what? The marginal product of capital dk/dl, right? So we have totally differentiated the production function, right? And when we do that, we know that just like in consumer theory, like we derived, the marginal rate of substitution, labor for capital, would be the negative of the marginal product of labor and marginal products of capital, right? So this gives us our slope, which is the marginal rate of substitution between labor and capital. And you see that as you move down the isoquant, the rate of substitution decreases, and that is the diminishing marginal rate of substitution. This is a restriction that is placed on production by the technology that is used. No matter the technology you use, a firm requires some amount of capital and labor, right? So that is why the rate of substitution declines as you move down the isoquants. Right, so in terms of marginal products and average marginal rate of technical substitution, we know that the marginal rate of technical substitution is the slope of the isoquant, and the ratio of the marginal rate product of labor and marginal product of capital give us the slope of the isoquant, right? So we have our typical isoquant, where here we would want to see which regions are better to operate in and which regions are not. In terms of the economic regions are the non-shaded area where it is effective and efficient for a firm to operate within this region and not operate within the non-economic region, because it becomes less cost effective to be picking more of one factor and straining the technology to produce the given level of output. So in terms of elasticity of substitution, we want to see how the technology allows labor to be substituted for capital and vice versa, right? So that will mean we'll be taking the second order derivative of the marginal product of what? Capital and labor. And when we do that, so D into bracket K over L, right, divided by this, which is the MRTS over MRTS, gives us this expression. So in terms of logarithm, alternatively, right, so we are looking at D K over L, the marginal rate of technical substitution between capital and labor. It will be D ln KL over D ln marginal rate of substitution. That shows us how relaxed or how a firm can substitute one factor of production for another, right? So closely related, we want to look at returns to scale. That is, if a firm increases both capital and labor, will output double or triple, or how? It depends on the scale, returns to scale of the technology that is being used. So here we have increasing returns to scale, constant returns to scale, and decreasing returns to scale. So with increasing returns to scale, the production function which exhibits this means that with a percentage increase in input, it will be followed by a larger percentage increase in output, right? So you increase input by 10%, output will probably increase by 30–20% instead of the 10% increase. And with a constant returns to scale, so from this we can tell that a production function that exhibits increasing returns to scale is of this form. Then we have a constant returns to scale that when you increase K and L by a factor of 2, output increases by 2, right? So that is constant. Then we have a scenario where when you increase K and L by a factor of 2, output increases by what? Less than 2. So it means that we have a decreasing returns to scale. Here, when a percentage increase in input is followed by a smaller percentage increase in output, then we have a decreasing returns to scale. But in terms of returns to scale, we want to see how output increases when labor and capital are increased, basically. So I would want you to read further on this one. Then in terms of technological progress, so although firms are assumed to be producing efficiently, they all may not be equally productive, right? So some firms may be innovating in terms of management skills and organization, technical innovation, and all that makes some firms more productive than others. So in terms of technical progress, it's an advancement in a firm's knowledge that allows more output to be produced from the same input, right? So when a firm is able to combine same amount of labor and capital to produce more output, then there is an advancement in the technology that is using. In terms of the organization, I mean, for example, mass and automated production of an output may also alter the production function by increasing input. So I would urge you to read further on the long run production, particularly with respect to economies of scale, right, technical and production efficiency, and the rest of the concepts that we have been introduced to. I have a section question here for you, and the section question is: given this Cobb-Douglas production function where A and L, capital A, small a and b are constant, determine the marginal and average product of labor, determine the marginal rate of substitution. And this is also a scenario that you can try your hands on. Thank you very much and all the best.